Hello, in this video I'm going to be introducing you to rotations in 3D space. So this is different to 2D because rather than rotating about a point in space, we rotate about a whole line or an axis instead. So we're going to start off with a nice animation that's hopefully going to explain how this works, and then we're going to look at 3 examples where we're looking at 90, 180 and 270 degree rotations about different axes. I'll timestamp each part of the video below so you can skip through to whichever part you want to see, and if it is useful, please do like and subscribe. Okay, so before we start, I want to make it really clear what's happening when we're rotating about an axis. And so you can see here we've got the 3D coordinate space, and I'm going to mark on the point 1, 2, 0. So you can see that's been marked on like so. Now say I wanted to rotate this point about the x-axis by 90 degrees anti-clockwise. Well, to do that, what we're going to do is imagine we're looking straight down the x-axis like this. Okay, so now I can just see my y and z axis, and the x-axis is coming out towards us. Now, if I were to rotate this point here by 90 degrees anti-clockwise, it's going to go round and hit up here, and it's going to have the new coordinate 1, 0, 2. And so if we take a look at this now, you can see that the x value has remained invariant or fixed under this rotation. And so when we're rotating about the x-axis, our x-coordinates are going to remain fixed. And by the same logic, if I was rotating about the y-axis, then the y-coordinate would remain fixed, and the same for the z. Now the reason I'm showing this is one, to hopefully give a bit more understanding, but also I'm going to be drawing this sort of view in a second when I work through some questions, and so I want to make it really clear what I'm drawing when I'm doing that. So let's take a look at the first question then. Okay, so let's see what's going to happen then with this question here, where we need to find the rotation matrix representing a rotation of 90 degrees anti-clockwise about the x-axis. So you can see here I've labelled on with this red arrow the rotation that's going to happen. And to find this rotation matrix, we're going to do what we always do, which is look at what happens to the points 1, 0, 0, 0, 1, 0 and 0, 0, 1. So like in the animation or graph that I just showed, what I'm going to do is imagine I'm looking straight down the x-axis, and I could draw what that would look like. I'd have my y-axis here like this, I'd have my z-axis, and then my x-axis you could imagine would be coming straight towards me like so. So let's see what happens to the points 0, 1, 0, so I'll mark that on, 0, 1, 0 and 0, 0, 1 under this rotation. I would draw on the point 1, 0, 0, but it wouldn't move, so there's not much point drawing it on. Well, under this 90 degree rotation, the point 0, 1, 0, that's going to be rotated round to here, and it's going to have the new coordinates 0, 0, 1. And the point 0, 0, 1 under this 90 degree rotation is going to move round to this point here with the coordinates 0, negative 1, 0. So let's find this rotation matrix. Well, it's going to have a first column of 1, 0, 0 as our point 1, 0, 0 is invariant under this rotation. The point 0, 1, 0 has moved to the point 0, 0, 1. And the point 0, 0, 1 has moved to the point 0, negative 1, 0. And this here would be our rotation matrix. Let's now have a look at this example where we are finding a rotation matrix to represent a 180 degree rotation anti-clockwise, but this time about the y-axis. So you can see here I've drawn on my red arrow showing us how we're rotating round, and imagine I was to look down that y-axis. Well, it would look something like this. I would have my x-axis here, I would have my z-axis coming up like this, and then let me mark on some key points that I'm interested in. Well, I would have my point over here 1, 0, 0, and on the z-axis up here, for example, I would have the point 0, 0, 1. Now we're performing a rotation of 180 degrees anti-clockwise. So my point 1, 0, 0, well, that's going to rotate around 90, 180 and become over here at the point negative 1, 0, 0. Now this is quite strange because this is the positive direction of my x-axis. Hopefully you can imagine if I was to look down this y-axis, then this positive x direction would be to the left, but that's kind of, I suppose, not usually what we're looking at. The point 0, 0, 1 under a 180 degree rotation would move around to a point down here somewhere, which would have the coordinates 0, 0, negative 1. And so my rotation matrix, say M, would be, well, the point 1, 0, 0 has moved to the point negative 1, 0, 0. Well, my y coordinate, or the point 0, 1, 0 is fixed, and the point 0, 0, 1 has moved to the point 0, 0, negative 1. And finally, let's look at a rotation which is 270 degrees anti-clockwise, but this time about the z-axis. So now imagine I was looking straight down the z-axis. Let me draw this out. Well, I would have my x-axis here, and then let me draw it like this. I would have my y-axis like so. Let me mark on my points. So I've got the point 1, 0, 0, and then on my y-axis the point 0, 1, 0. We're doing a rotation 270 degrees anti-clockwise. So let me actually move this down a bit more. So the point 1, 0, 0, where is that going to go? Well, it's around 90, 180, 270 degrees. So it's going to be at the point 0, negative 1, 0. And my point 0, 1, 0, round 90, 180, 270, it's now at the point 1, 0, 0. And so this rotation matrix M is going to have the column, or is going to be made up of the first column being 0, negative 1, 0. My second column being 1, 0, 0. And finally, my third column is going to remain fixed because that is the Z coordinate. So hopefully this video helped. If it did, please do like and subscribe, and go over to my channel where I have tons of other A-level maths tutorials. Thanks for watching.